Hi, Dr.Ray here, covering another epi question. So let's just pause for a second, and if you can, stop and try to answer the question by looking at the question lead-in, looking at the question answer choices, and the stem. Okay, go for it. All right, so let's take a look at the question lead-in. Can we answer this question with just the lead-in? Which of the following statements best characterizes the distinction between probabilistic and non-probabilistic sampling methods? We might actually be able to answer this question by just looking at this. So we're trying to figure out which of the following is correct about non-probabilistic and probabilistic. So let's talk a little bit about probabilistic. So probabilistic is broken up into really three different kinds of categories. There are some others, but let's just talk about these three. So there's simple, right? And simple is looking at a population and then going into two different samples, so experimental and control. And if there are people here in the population, they have about an equal chance. Right? So probabilistic means chance, the probability or chance of becoming in the experimental or the control. You see this in RCTs, randomized controlled trials. So about a 50% chance of getting into these two different groups. Then there is stratified. And so stratified often breaks these groups up into different characteristics. So you might have ethnicity. You might have BMI. You might have different health factors like cardiovascular disease versus MI versus congestive heart failure, right? So these three are different buckets. And if you have three different buckets, or if you have this breakdown, we might even have age groups, right? So below 30, 30 to 50, and then above 50. So then you can see that there is a less than equal chance because we're going to be breaking these up into multiple different groups based on the stratification. So when we stratify, we are stratifying amongst these different groups, right? So we might have people that are in our experimental group, but then we break them up into below 30, 30 to 50, above 50. And then we might have in our control group below 30, 30 to 50, and above 50. So that is the stratified. And then there is the cluster. And so cluster is often seen, it's a somewhat similar to this, also has a less than equal chance. But it's somewhat similar to stratified, except that we might use things like location or country, right? And so you can imagine location might be like zip code. So breaking things up into groups or clusters of patients within the entire population by zip code, and that will define a probabilistic. Non-probabilistic would be something like convenience sampling, right? And so convenience sampling might be, well, everybody that shows up today are the ones that we're actually going to do the study and we're going to enroll them in. Anybody else that we reached out to via email or tried to say that they were going to show up and that kind of stuff are not going to be included. So we only include the ones that showed up today. That is convenience sampling. That is going to be an issue with our generalizability and the validity, because the people that showed up versus the people that did not show up might actually be unbalanced compared to the population. So there might have been a reason why the people that showed up have, and it doesn't represent our entire population. So there are issues with that. So that's non-probabilistic. So let's go back to here. Answer choice A, non-probabilistic sampling is inherently more accurate than probabilistic. Well, we kind of talked about that already. Non-probabilistic is not necessarily more accurate. If anything, there's going to be there's more potential for having unbalanced groups if we are doing non-probabilistic. If we are using chance and we are selecting based on probability of going into a group, then there's going to be more accuracy with our outcomes and our generalizability. So I'm actually going to say that that one's not correct. Non-probabilistic sampling typically yields more representative samples. Oh, that's not true, because we said that here, that when we are not selecting people in our groups by chance, then there's less probability of being generalizable to our population. So that one makes no sense either. Probabilistic sampling assures randomness and selection, while non-probabilistic sampling does not guarantee. That's true. I like that one. Let's go to the other ones before I commit to one, but that one I like. Probabilistic sampling is generally more cost-effective. Now, we don't know if that's true. It might be true, but there's a lot more things that go into this. So, what if your probabilistic sampling was a bigger cohort or a bigger sample of people? So you had 1,000 people, and then your non-probabilistic, you only had 100 people. Well, that would make the probabilistic maybe even more expensive. So I don't think this is true for all situations. So I'm going to rule that one out. Probabilistic sampling is usually more biased. Well, when you talk about bias, you're talking about having balances within your groups. You're talking about representativeness. You're talking about generalizability. You're talking about, we're having, I believe, and what it shows here is that we have less bias, not more bias. We probably have more unbalanced groups, i.e., more bias by doing non-probabilistic, because our unbalanced populations are going to be there. So that one I'm going to rule out. So it looks like this one is the most correct, C. Let's go back to the question stem. A researcher aims to estimate the prevalence of diabetes. So remember, the prevalence is the total number that have disease, right? All cases divided by the total population. And that is prevalence. And this is happening at a specific time. All right. In a city of 1 million residents, so we have a sample of 1 million, or a population of 1 million. In contemplating the study design, the researcher is considering various sampling methods to select participants. So we didn't actually need this, because none of this information actually played into choosing the correct answer choice. So the lead-in was all we needed to choose. So I'm going to go with C being the most correct answer. I hope you agree.